Hi, in this video I'm going to talk about consensus algorithms and block mining. Our content is peer-to-peer network, what is consensus algorithm, the Byzantine Generals Problem, and the proof of work consensus algorithm. So let us talk about peer-to-peer network. Peer-to-peer networks are a type of computer network in which two or more computers are connected and share resources without the need for a central server. Instead of relying on a single central server to manage and distribute data, P2P networks allow computers to communicate and share information directly with each other. Okay, to be able to understand peer-to-peer network, let us first understand client-server network. Here we have a central database. A client-server network is a type of computer network in which one or more computers called servers provide data and resources to other computers called clients. So here, basically, you can be a client trying to fetch some information from this database. For example, when you are messaging on WhatsApp or Telegram, you are basically sending message to that database, and your friend also getting the same message from that database. And there's a central authority here. If the database of Telegram or WhatsApp is down, this means you cannot send a message and your friend cannot get the message. As when it comes to peer-to-peer network, it's not a centralized system. Peer-to-peer network is a type of a computer in which two or more computers are connected and share resources without the need for a central server, which makes this transparent and secure. So let us understand their differences one by one. Here we will talk about architecture, scalability, security, and efficiency. Server-client networks based on architecture centralized with one or more servers providing data and resources to clients. When it comes to peer-to-peer networks, they are decentralized. There is no central server. Each peer acts as both a client and a server, allowing users to share files and data directly with each other. Scalability. In a server-client network, it may require additional service to handle an increase in the requests or clients. In a peer-to-peer network, it can be more scalable as each peer can act as both a client and a server, allowing the network to handle more requests without the need for additional service. Security. Server-client networks may be more vulnerable to security threats as there is a central point of control that could be targeted by hackers. Peer-to-peer networks, on the other hand, may be more secure as there is no central point of control that could be targeted by hackers. However, peer-to-peer networks can also be more vulnerable in some cases as each peer is responsible for securing its own data and resources. Efficiency. Server-client networks can be more efficient as all data and resources are stored and managed on a central server, and peer-to-peer networks may be less efficient as data and resources are distributed across multiple peers and may require multiple hops to reach their destination. So what is Byzantine General Problems? Before we get into consensus algorithms, we first need to understand it. The Byzantine Generals Problem, also known as Byzantine fault tolerance problem, is a hypothetical scenario that demonstrates the difficulty of achieving consensus in a distributed system when some nodes may not be trustworthy. A group of generals are around an enemy city. In this example, they must decide on a strategy for attacking or retreating, and they must communicate to come to a consensus. However, some of the generals may be traitors who try to prevent the loyal generals from reaching an agreement. In this regard, okay, we are attacking an enemy city, and there are some generals. And the problem gets its name from a historical event in the Byzantine Empire, where a group of Byzantine generals were encamped around an enemy city and had to communicate with each other, like in this animation. This problem is relevant to consensus algorithms because it highlights the challenges of achieving consensus in a distributed system. Consensus algorithms are designed to solve the Byzantine generals problem by providing a way for nodes to reach agreement on a single value despite untrustworthy nodes. Here we have some generals around the city, and they all say that, okay, let's attack. And when they want to retreat, they all say that, okay, let's retreat. But there might be some traders who are saying something different, like, okay, do I want to retreat or do I want to attack? So this can confuse the whole system. So in this regard, what we are trying to understand, if we want to attack, we need a consensus algorithm. We need to reach an agreement. And when they all want to attack, this peer also should say, okay, let's attack. But he or she can also say, okay, let's retrieve. So that's the problem about this example, and this is linked to the consensus algorithms. So what is a consensus algorithm? Consensus algorithms are protocols or processes that are used to achieve agreement on a single value among a group of distributed processes or systems. These algorithms can be evaluated based on several attributes, including fault tolerance, scalability, security, and decentralization. Let us talk about fault tolerance. It comes from Byzantine Generals Problem. A fault-tolerant consensus algorithm can reach consensus even when some nodes fail or behave incorrectly. For example, it may be able to function with unavailable or conflicting nodes. In our previous examples, there were 3 generals who say, okay, let's attack, and one said, okay, retreat. In this regard, the majority will be valid and the generals will attack. Scalability. Scalability refers to the ability of a consensus algorithm to handle an increase in the number of nodes or the volume of transactions. A scalable consensus algorithm should be able to continue reaching consensus efficiently as the size of the network increases. Security. The security of a consensus algorithm refers to its ability to protect against attacks or other threats. For example, a secure consensus algorithm might use cryptographic techniques to ensure that transactions are secure and cannot be altered. Decentralization. Decentralization refers to the distribution of control and decision-making power among the participating nodes in a network. A decentralized consensus algorithm relies on multiple nodes to reach consensus rather than a single central authority. Let us talk about proof-of-work consensus algorithm, which is used by Bitcoin, for example. The proof-of-work mechanism is a type of consensus algorithm that is used to achieve distributed consensus in a distributed system. The key points about proof-of-work mechanism. It is used to achieve distributed consensus in a distributed system. It requires miners to solve a computational puzzle in order to create new blocks. The first miner to solve the puzzle is allowed to create a new block and is rewarded with tokens or a block reward. The puzzle is designed to be difficult to solve, but it's easy to verify once it has been solved. It helps secure the network by requiring a significant amount of computational power to solve the puzzle and by making it easy for other nodes to verify the solution. To keep the block production rate limited, miners must solve a puzzle for each block. This puzzle is about the block hash being in a certain format. For example, miners should get a hash value whose first 4 digits are 0. In this regard, what we are trying to do as miners, we are trying to get this 4 leading zeros. When we get it, we can say that, okay, I mined the block. In this way, malicious miners are prevented from producing blocks one after the other. Okay, let us understand it in detail. In our previous lectures, I mentioned about difficulty and nonce value, but I have mentioned that I want to explain them in later lectures, and we'll also see them in blockchain demo in detail. So we have a block header, and in this block header we have version, previous block hash, timestamp, difficulty, nonce, and Merkle root. In this regard, to be able to understand difficulty and nonce value is really important. So, for example, what is nonce value? When we try to find a hash value, every time we try it, we need to increase the nonce value by 1. When we do that, if the nonce value is a big number, this means that we have found the hash value in a lot of trials. So, here is our block hash. And I want 4 leading zeros to mine the block. It can be 8, it can be 15, it can be 20 zeros as well. This is actually called difficulty level. If there are a lot of miners, the number of zeros will be increased because we don't want everyone can get the value easily. But if there aren't a lot of miners in the system, difficulty level can be decreased, meaning that the number of leading zeros can be decreased. Okay, so then I will increase my nonce value, meaning that I will try to find a hash with 4 leading zeros. I couldn't find it, so I will increase nonce value again by 1. I still couldn't find it. Then I will try to do the same thing again. So I got it, meaning that with some nonce value, I got the hash value with 4 leading zeros, and I can say that I have found the right hash value, then I mined it. Okay, and at the end of this, I need to get a reward because I mined it. I use energy, I took my time, and there's gonna be a block reward for me after I do all of those things. This is how proof of work consensus algorithm works. We'll also have a blockchain demo on it, and you will have a thorough understanding. If you have the idea here, that's enough for me. So that's gonna do it for this video. I will see you in the next one.